The next example is stock prices. Predicting stock prices is of great interest in the financial sector. Now we can take the past data of closing prices and try to fit a regular probability distribution without considering the time series element. Okay. So uh, in the short run at least, the stock prices are supposed to move in what is called a random walk um, process, and that is would be like the next step that the price takes. Okay, so it has a mean of zero, that is the change, and then there is a standard deviation involved, and it can go either up or down. So that is the general principle. And what we're going to do is to take the stock price for 10 years and we will try to compare what happens when we assume the mean is stationary but the variance is not. Okay. So we're going to look at the continuous compounding of the closing price. So we take a percentage change, right? And remember that if you're assuming uh, continuous compounding, then that percentage change is ln of the current value divided by the previous value. So that gives us the change. Now let's go ahead and prepare a time series plot of these. Okay, let's first plot that. Okay, insert, let's say that one. Okay, so that's our adjusted close. Okay, now let's add to it. Okay, the percentage change. Now percentage change you have only from the second day onwards, and the y values are here. Okay, click OK. All right. Okay, so now we have adjusted close, the blue line, and the red line is the percentage change. So obviously there is a problem because this is not in the same scale. So we have to add secondary axis. Okay, so select the points, right click, format axis, and then select secondary axis. So now that gives us two different axes, right? And then let's change this dates getting all squished together. So we have okay. So major is, it says 500. So let's see if we make it to 1,000. Okay, so it gets spread out, maybe a little less, 800. Okay, now we want to get rid of that blank spaces here, so which means we have to change the minimum and the maximum, and the dates are actually integer values, so we want to get the integer value of this date, put it here, and the integer value of the last date and put it here in the maximum, right? So let's take this date, copy it here, and then let's take the last date, okay, and copy it here. All right, so now let's highlight the two and change the format from date to general, so that will give you the numbers. So let's take that number and put it there, and here we'll put 43532. Okay, so that's gonna make it. Okay, let's add legend, and let's put the legend at the bottom. Okay, chart title will be adjusted close and percentage change. Okay, so, we can have access titles here. That would be adjusted close, and that would be percentage change. Well, in that case, let's change the title to what, Amazon stock price data. Okay, no, we don't need that title, so let's get rid of that. So you can see that there is trend, overall trend. Okay, but if you take the percentage change, that becomes stationary. The percentage change becomes stationary. So that could be one thing that would be beneficial. So what we're going to do is to, since this is stationary, we can fit a probability distribution for this and simulate that. And compare that again, since this shows a non-stationary pattern, we can take the adjusted close and try to fit time series model, and then compare these two and see, well, try to understand which model would be better.